Hi, this is Lu, and in this video, I'm explaining the midterm problem 6. And the problem statement is very long, so instead of writing it all out, I summarize what the code and XML are doing, and then explain each subproblem clearly. And then, so this Python program load a Mujoko model from an XML string. Create a world with 3 bodies, A to B to C, and each connected by hand joints. The script runs a simulation for a certain duration and frame rate, and renders what the camera sees. The question asked me to explain specific lines in the XML and in the Python code, what the parameters means, and finally to draw what the camera sees at 2 different times. Okay, so for part 1, I'm doing the meaning of noted XML lines. So this XML defines the structure of the robots. So this one, the body name A is a robot body sitting on the world, and inside A there is body name equals to B, and inside B there are body names equals to C. So this is the kinematics chain A to B to C. So each body has a join type hinge, so these two, and the geom type equals to box line, assign a shape and size so Mujoko knows what to draw. And the camera element define a fixed camera in the world with post at the 0, -5, 0. Yep, post position. And pointing toward the scenes. Overall, the XML describe the full physical structure and appearance of the model. Okay, for part B, I'm doing the meaning of duration and frame rate. Okay, so this one. In the Python script, duration equals to 10 means the simulation runs for 10 seconds of simulated time. Okay, so for this one, frame rate equals to 30 means we record 30 frames per second. So total rendered frames is equal to 10 times 30. So the total rendered frame is equal to 300. These two variables only affect rendering frequency, not physics. For part C, meaning of the part C meaning of the data, this one. So this line set the initial joint angle of the 2 hinge joints. So joint 1 is equal to 0, and then joint 2 is equal to 90. So this one, 90 degrees. So because Mujoko uses radians, the code converts degrees to radians. This means body B starts unrotated relative to A, and body C starts rotated 90 degrees about the y-axis relative to B. Okay, so then we need to draw what camera C at t equals to 0 and t equals to 0.1, and so at t equals to 0, nothing has moved yet. So joint 1 is equal to 0, joint 2 is equal to 90 degrees. So A is the base, and then B extend forward to the y direction, and C rotates upward, upward depending on orientation because of the 90 degrees rotation about the y-axis. So the camera see a 3-link chain with the last segment bend 90 degrees. Okay. So because inside the while loop, while data, that time, duration, so Mujoko applies physics, gravity disabled, but join 1 and join 2 are not actuated, so they should remain fixed unless model had default dampening, but the camera sees time changing because the simulator render multiple frames. So t is equal to 0.1 second. Simplify is the same poster unless the joint are moved. Yeah. So at t equals to 0.1 second, there's no joint input and no control acting on the system, and gravity is disabled in the XML. Therefore, the bodies do not move. Both joint angles remain the same as initial value. So the camera sees almost the same configuration as at t equals to 0, just rendered at the later frame. Okay, so to summarize the problem 6, so first one, the XML defined a free body chain with the hand joints. The Python script loaded the model, set a joint angle, step physics, and renders frames. And then the duration is equal to 10 and frame rate is equal to 30. Control how long and how often frames are captured. Because joints are not actuated and gravity is disabled, the pose at t equals to 0 and t equals to 0.1 second is essentially identical. Okay, this is my problem 6, and I am Yuan Shou Liu, and thank you for watching.